Hi, Ivan Poupyrev.
Hello.
Hello.
Everybody.
You have worked for Sony and Disney and now working for Google. And in your presentation, you will show us how to bring new technology into ordinary people's life. And I hope that you can see the audience and hear me fine.
Yes, I can hear. Everybody can hear me? Everything's good.
Thank you. Go ahead and welcome to the conference, Ivan.
Thank you. So, sorry I have to be virtually present at the conference. I've been trying to make sense of technology all my life. And I think the only way to make, or maybe one of the ways to make sense of technology and how to bring it into the everyday life is to invent it or to use it in an interesting way, in a creative way. So in this quest, next slide, in this quest, I moved to multiple companies, and now currently I'm working for Google. And but originally actually coming from the USSR. Next slide. And USSR is now Russia. It's not only Kalashnikovs and vodka over there, and there's a lot of other things. And as a kid, I was very inspired by the Russian avant-garde, in particular Russian constructivism. So this is a very famous poster done in the 1920s, 20s, 30s, I think, by one of the Russian photographers, modern art photographers. Next slide. This is a original picture of that. At that time, we didn't have people didn't have Photoshop, so it was actual photograph taken and put together. Next slide. And the next, this is another very famous painting, design probably seen many times. Work being like this original poster inspired a lot of modern designs. And the next slide, there's this original picture of that slide, and this is work by Alexander Rodchenko, who is one of my, I wouldn't say a hero, but somebody who inspired me very well. Actually, she's sitting on a chair and she's yelling up, right? So her hair is looking up from the chair. Picture is taken horizontally. So he was a master of making this kind of unusual angles. So next slide. So in the Rodchenko, in his letter from 1920s, he wrote that our things in our hands must be equals. They must be comrades, not mournful slaves. And this quote kind of struck me a long time ago as something very profound, the way we think about technology, the way we treat technology. Because today, we treat our technology as a slave, right? So it's a factory, and we're making things with them. We're trying to put it in our advantage, and it kind of that was always felt a little bit dreadful for me. Very kind of this functional industrial way to use and think about technology, and I've been always thinking about technology in a more playful way. Next slide. And like a children, we don't think about toys we're playing with as being technology, but we create things as we play with them. We create a story with technology, and then we construct things. So, and this is kind of slightly maybe very naive way to think about technology, not very serious. And before these days, now everything is digital. You can work for Google, but in early days, there's very few places you can work actually and do kind of playful stuff. And that was consumer electronic industry, one of them. Next slide. And consumer electronic industry making gadgets. You don't make anything useful. You're making playful, colorful things, colorful toys. And that's why I went to work for Sony. Next slide. And I spent in Sony about 8 years working on gadgets. Next slide. So in the world of consumer electronics, your friend is your gadget, or gadget is your friend. And you spend basically trying to think how you can make this gadget more appealing to you, how you can make technology which makes this gadget a real friend. And one of the first projects I did at Sony, next slide, was try to make interfaces where you can feel tactile sensation on touch screen. So you can press the button on the touch screen and you can feel the button, virtual button, clicking under your finger like a real button, right? So the whole idea was, what I was interested in is about creating devices where you can feel devices talking back to you, right? Where they can touch you back, So, and that's technology called Touch Engine, and we did it in 2001 before the iPhone, before the touch screens became popular. What it had these piezo actuators. We designed very custom piezo actuators, you can see in this picture. And it's a small beams of piezo material which would bend up and down depending on the polarity of voltage we apply to the actuators. And what you do, you put the actuator in between this beam, you put it in between the screen and the touch panel. So when the beam bends, it pushes pushes touch panel against your finger, and you can feel it's clicking, kind of very strong click sensation under your finger. And this was the very first kind of approach, very first tactile user interface for touchscreens, which we invented at the time. And it was amazingly effective. It was amazingly effective, and people really liked it. And next slide. So Sony went off and made a product out of it. Next slide. And so this was the press release about this first tactile feedback device for this unit which we're selling with Sony. Next slide. And we went. I went to the whole thing to the factory production. So I spent about several months working in a factory in Japan, trying to set up a production environment. This is a woman. She is cutting this piezo actuators using laser-guided diamond saw. There's only two ways you can cut piezo, using diamond saw and plasma cutter. Next slide. And this was a party when we celebrated, when we started when we launched the product. It was a little party. Next slide. That was me. On the slide. Can you see this? Can you see the round? Yeah. Anyway, I had a beer at that time, and then and I was very proud of this thing. Next slide. Because what we did, we took it and put it into the remote controller with tactile feedback devices, and so it was a world first touchscreen consumer product where you can feel buttons and virtual buttons on the screen by touching them. Right. So I'm kind of very proud of this work. But what surprised me at the time is that designers, which we had at Sony, they completely replicated functionality. They put all the functionality which was on a touchscreen was placed on the device itself. You can see there's buttons and wheels on the bottom of the remote controller. And they told me that people will never use touchscreen only devices because people want buttons. It was before, again, it was done before the iPhone. The next one. So that's kind of work I've been trying to explore. How can we make devices we hold in our hand more as a friend which talks to you or listens to you and being your friend rather than have a kind of functional properties which is being useful. A lot of people doing this kind of stuff. So in this project, for example, we created a very small recording devices which are attached to the book. And then next slide, you can, when you open the book, switch next. And then when you read the book for the child, when you open the book, this little device is recording your conversation with the child around the book. And when you close it, stop recording. So later you can record conversation with your mother. Next slide. In this project, we were exploring how can you make bendable computers, how we can use physical deformation of the devices, a interaction language which you can use to control information on the small handheld gadgets. At that time, we were just started playing with flexible displays. Again, it was really early at the time. We couldn't get them, so we built a bunch of prototypes and designed a whole complex interface. It's like, but the idea was that you can control your device only by bending it and having touch screen or touch sliding device on your back. So you can slide with your fingers on the back and control information without obscuring the screen. Next slide. So the flexible display is still not there, but again, this work was done before the touchscreen kind of explosion. So we were talking about multi-touch at that time. And now, once touchscreen came up, the Sony actually put touchscreen on the back of the PlayStation Vita. So some of that work went to the present Sony products. Anyway, so this was my early exploration of work of how could we use technology in a more playful way. And what always concerned me, next slide, is that it's all kind of gadgets, right? You're thinking about these objects, and you keep making them. Next slide. And it's not really clear how sustainable it is, right? So, I mean, how many gadgets do we need? How many objects can we do? How many things we can have in our life? Next slide. Because most of our gadgets end up in this big pile of rubbish somewhere in the third world countries. polluting environment, and basically just we're wasting resources which don't come back. So at some point I started wondering, how can we think about beyond gadgets? Next slide. And how can we take this kind of technology-driven interactivity, technology-driven playfulness into the entire world around us, right? And people have been talking about augmented reality for a long time. I've done a lot of work on augmented reality before, and and right now it's kind of this growing field. Next slide. And it's already here, right? So already our world is being changed, and already our world is being being infused with interactivity. But if you really want to make it right, I think you have to. I thought I had to really make it right. So I don't want to do like this normal things. So I went to work for Disney. Next slide. And because Disney already have this kind of artificial environments which you get a lot of freedom to play with. Next slide. It is the happiest place on earth, clearly. So by the way, this is interesting. This is some slide I picked up from some random Disney demonstrations, but this is actually Tom Cruise's daughter, I think, on the picture. I'm not sure. Anyway, so so Disney is the happiest place on earth, but Disney has a significant problem. Next slide. Is that it's very expensive to build Disneyland or Disney World and all these big, giant spaces, right? Once you build it, you cannot really modify it. You can't really go and turn it down and make a new version of Disneyland. It's a lot of money, right? So the idea was, how can we bring interactivity into existing spaces? How we can take existing spaces and change their behavior, change their functionality? How can we turn the world into the gadget? Next slide. The way I used to put it when I was working at Disney, how we can make everything alive? How we can take giant environments and make them live and responsive? So, and you cannot really achieve easily with existing technology, because our today's technology is not done for the environment. The most of the technology we have is done to make tools, like gadgets, like SONY consumer electronic products. Next slide. So we build, this is an example of the sensor which we had to invent called Touché. If you press the click button, it will play a video. Yeah, so it's the idea of the project is that you create a sensor which is super simple. You take a single wire, you connect an object from the store to the wire, and this object starts being able to recognize your gestures in real time without any instrumentation. So this is a doorknob we bought from normal store, right? Let's take a look at the game. You take a wire, you connect to our little sensor board, and now this doorknob can know how you're touching it. I touch it with one finger, or with two fingers, with the hand, or you have a circle, and so on and so on. A very, very simple instrumentation, very fluid instrumentation can be used to add this kind of interactivity to real objects. Next slide. So, and the important thing is that sensor is universal. It can be used to add interaction to almost anything without any changes. In this case, we add interactivity to the table. We put electrode inside of the table. So now you can put your hands on the table, and the table knows how you're sitting in front of it. Are you using both hands on the table? Are you putting like on the part of the table, one hand, two hands, if you're close, if you're far? All the things can be recognized just from the single sensor, single wire connection. Next one. And it doesn't have to be a table, it doesn't have to be an object, one more time. We can make very fluid object interactive, like a pool of water can be interactive, right? And this is something actually like things like Disney are very interested in, because there's a lot of water in the Disneyland. A lot of places where you can add like really fluid interactivity invisibly to the pools of water inside of Disney. Right? So in this case, this fish tank becoming like a little touch screen, so you can touch and you know how you're touching. Next. Yeah, and then this is human body can also become interactive. Human body can be and should be kind of our interactive medium. We can infect or inject with technology. So here, system can recognize how you're touching your own hands. It can know if you're touching on your fingers, you're touching multiple fingers, you're folding them together, or touching other body parts of your body. Next slide. So how does it work? I give you a very simple explanation. So the idea is very simple, right? The idea is very simple, but nobody done it before for some reason. Next slide. And the idea is based on the fact that, this is a form of capacitive sensing. So we have an electrode, right, which you touch. And the electrode can be anything: water, plants, human body, anything you want. And what happens there is that, next slide, that the path of the signal from the electrode through to the human body, to the ground, depends on the frequency of the signal. This is a very basic fact of physics. So next slide. So as you're changing the frequency, the path of the signal going through your body will change, right? Next slide. Next slide. Next slide, yeah. So you can see now there's all this, depending on the frequency, the path of the signal would go to different parts of your body. Now, if you take off your leg, for example, you're a pirate. Next slide. And if you're a pirate, what happens is that now when you try to apply the same signals through your body, next slide. Next one, next one, next one, next one. Stop. Go back. You can see that the signal does go so certain frequency. The signal goes to a part of the body, but a certain frequency it stops and being stopped by your leg, by your wooden leg now, because you're a pirate, right? And the signal on the left corner, you can see it's on the top corner, is changing. And by recognizing the changes in the signal, we can sense how your leg touching the ground or not touching the ground. That's the basic principle of the sensor. Next slide. Now, the interesting thing about that is that, as we talked, you can make anything interactive. It doesn't have to be objects. It can be anything you want. Next slide. In this case, we decided to interact. We can, for example, make plants interactive, right? In this case, you take a plant and you put just a single electrode inside of the plant, connect it against our sensor, very little modifications. And now the plant can know where you're touching. The plant becomes your instrument to interact with the medium, right? So you can see as a person slides on the finger, you know where you're touching. You can put this. It can also know proximity and how much you touch the object, right? So if you're touching a little bit, or you're touching a lot, and you can also create visual effects. It's quite sensitive. Or you can make a calendar out of your plant. So I don't know why you would do this, but we did it anyway. Because I hate my calendar. Anyway, next slide. So what's the interesting thing about it is now plants have there's a huge variety of plants, right? And every plant can have its own personality. You can think about personality of the plants can be expressed now for the first time in the history of humanity and the universe. The plants can now express their personality and talk back to people about their feelings. Next slide. So we made this project with a studio in Berlin, where we combined visual and audio representation with the plant and give the plants personality and kind of a language. And they don't speak human language, but they express what they feel through sound. Next slide. So orchid doesn't like to be touched because it's very fragile and it's afraid it's going to be destroyed. So whenever you're touching it too strongly, it starts hissing at you and create this kind of visual effects around its own body. And this plant doesn't really care. It's like to be touched. So the more you touch it, the stronger the effects coming out from the plant. These particles coming out from it. And we built a whole bunch of those plants and kind of try to look at them from different angles and see how the plants can be used to tell stories and represent something in the environments we're building this thing. Next slide. And then I showed it to my boss, and he liked it. He said, "This is awesome." And next slide. This is installation. So this is a part of the Disney world where it's called in Orlando, which is called a drum place where there's a lot of drums. So we put a plant and we want to see if people are going to be playing with the plant like a drum. We'll be hitting the plant to create the drum sound. And it was actually quite successful. It was really impressive how quickly, particularly children, would grasp idea that you can use a plant as a musical instrument. And this has got this magical qualities with it.
Right, it should be up on a pedestal. And
so adults were less impressed.
Alright.
So yeah, whatever, interrupted plant, did that, done that, it's decent. But adolescence it was quite successful experiment in trying to bring interactivity into the parks and public environment through interactive plants. Next one. I also think this can be useful at some point. Next one. For example, if the plant can be your friend and you can watch TV with the plant and together if you don't have any other friends. And but also plants can be remote controlled, right? So like every leaf can control all of the channels, and if you don't take care of your plant, you start losing channels, and at the end you're going to only get stuck with the shopping channel. So that's you have to take care of your plants. Next one. Well, for example, it can be a button in the elevator, right? So if you want to take an elevator, you have to hurt yourself, right? So you either have to take the stairs and exercise and save energy, or you have to hurt yourself. Right? This kind of like negative reinforcement, I think, works quite well sometimes. Next one. Anyway, let's talk about the other project which we did at Disney, and it's about electrical power. Like, how can we create electrical power for the playful interactions? Is it possible to create electrical power from playful interaction? Next one. The power, like if you're talking about Internet of Things and augmented reality, intelligent computing, blah, 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 one of the things people often don't talk about is about the power. How are you going to deliver power to all the smart things around you, right? Because if there's no power, there's nothing works, so there's no point. It's not particularly intelligent because there's no power, right? Next one. So our approach was to use humans as a source of power, right? Can we use humans in interaction as a source of power? Next one. So, well, one way to do is like matrix. You just plug something to humans and make humans like a source of the chemical power. But we use different approach. We didn't go that evil way. Next one. This is a very simple set of. We created a so-called thing called paper generator, which is simple techniques to generate power using everyday materials. So you can have a paper, and you have a Teflon, and wrapping paper you can get from the flower shop, wires and tape. The next one. And using these materials, you can very quickly create very simple structures like this. This is one of them. There's many, and you will see them in a second. And now these structures can create electrical power. Just by tapping on this button, it's create electrical spikes. And now you can link this whole thing to some sort of electrical devices. Next one. And for example, you can light up LEDs, right? So as you're tapping on the button on the remote control, on the control of this rocket, you can see the rocket flies forward, right? Well, at least you can imagine it flies forward, right? So it's lighting up LEDs. Next one. Or you can create a game, right? So a person who's tapping faster has a LED blinking first, because we have a small storage circuit which stores energy, and the one who stores more energy wins the game. Again, no batteries, no connection to electrical outlet. Everything is done with paper and flexible materials, completely transparent. Next one. You can also turn simple displays on and off. This is e-paper, the one which is used in Kindle and other electrical e-book readers. And by this is simply turning on, but you can make very simple animation. The next slide. Here, by rubbing it, it creates it's turned them one by one, so you can create a very simple effect where the letters coming in, coming out, objects appear, objects disappear, and so on and so on. It's a super simple circuit. So in this one, we can create mechanical motion. So a cat can wave you from space. That's what we do. Or you can control some remote devices. This is Internet of Things in front of you. So when you can grab the little thing, it's controlled remotely in animations on the screen. So and there are a lot of other things you can do, and it's also very easy to make. You don't have to make it by hand. You can print it or do something else. Next one. Well, in this case, we're just printing it on a printer using silver ink. And then you can, next one, then you can connect a bunch of LEDs, and then they will work beautifully dozens of these can be light up with a simple structure. Next one. So how does it work? I'm running out of time. I would love to talk more, but I think there need some time to talk about stuff. So next one. So please email me. I'll send you the paper. The physics of this effects is actually really, really complicated. But somehow, as often happens, this very complicated physics translates into very simple structures you can build. Anyway, next slide. I'm finishing. I have 3 slides left. So let me do some conclusions. Can you go back? Yes. Some conclusions. So I guess I've been thinking a lot how, like, for a long time, why inventing technology, why we're trying to make technology. And recently, I've been reading the book about the people who went to the Everest and tried to capture the Everest. Right in the 20s, this person, his name is George Mallory. He spent multiple attempts to try to climb Everest, and he would fail all the time. And in the end, he died. And while he's doing this attempt, people ask him, "So why are you trying to get on the Everest? Why are you trying to get on the mountains?" And his answer was, next slide, because it's there, right? And so simply, I think if you ask me why we're making things, next slide, my answer probably be, after all these years of trying to make technology, think technology, next slide, is simply because we can. And that, I think, kind of my message to you. Thank you. Next slide. Thank you very much for your attention.